Welcome to Lights Out. I'm John Weiss,
I'm Andy Henderson.
and today we are going to talk about G's. Andy, you want to take a guess how many G's we're going to talk about?
Five of them.
5G. That's right. With us today is Thomas Fuerst. For the folks listening and watching who don't know Thomas Fuerst, he's been in the industry for, 15, 20 years, I think, Thomas.
Yeah.
Expert, everything related to 5G, IoT, telco, cloud computing, you name it. I think you've got it under your belt. Yeah.
No, absolutely. I've been around the block a few times and at different stages been responsible for marketing or business development around these technologies. So I'm glad to be here, John. Thanks.
Yeah, we're super excited to have you. And I had you're so knowledgeable. I had a tough time figuring out what I wanted to pick your brain about today, but I think, Andy and I were talking about 5G and what does it mean to industrial companies, manufacturers, and what Andy and I realized is I don't think we know a whole lot about what it means, quite frankly. We know a little bit about speed and being able to now remove the wired environments and go more wireless and things like that. But I was hoping we could kind of pick your brain a little bit today, and maybe you could start by telling us what is 5G? What does it all mean?
Yeah, no, it's a great place to start because I think there is a lot of misunderstanding about 5G and what it is and what it's not. And I say that because, frankly, 5G implies a linear progression from 4G and 3G and 2G, right? So if you go back into those standards, the wireless standards going back, into the 1980s with analog wireless, and the 90s with 2G voice, digital voice. The 2000s, we kind of get into 3G, and then 2010, 4G. So you see there's about a 10-year progression from technology from each generation of wireless. So it's real easy for folks to just focus on 5G as just, hey, better 4G, right? And it is, but it's so much more. It's so much more. You mentioned earlier some of my posts on LinkedIn. I'm often making the argument that we've done it a disservice by calling it 5G because it is so much different. So yeah, you think about what is 5G? It is in a nutshell the next generation of wireless technology. Like I said, every 10 years we get a new generation. What's interesting is as you go through those generations from 3G and then really with 4G, where you went from kind of the wireless internet to now, true mobile broadband and smartphone, the device is much more than just a phone. We call it a smartphone, but we all know it's really a computer, right?
It's our lifeline to work,
exactly,
to everything.
Yeah, and exactly, and what you saw was it started to then infiltrate, not just consumer voice or business voice, but now healthcare and shop floors with iPads and things like that. So this idea of just calling it a generation of wireless technology, it kind of falls apart, right? Because 4G was the mobile broadband, and so really what's great about 5G is that it kind of blows up that whole paradigm, if you will, right? It is a standard. Which is good. We like standards. It gets you economies of scale and allows you to use that device in different parts of the world and things like that. But it's the first, and you alluded to this already. It's the first technology to provide the throughput, reliability, and low latency of a wired connection like a Cat5 Ethernet, right, with the simplicity and portability of wireless. And it's really it's designed from the ground up with the standards to address a range of different applications across different industries.
So that's really the first time then, if I understand correctly, 5G is really the first time in really the telco and wireless history that we will have now the same type of speeds and connectivity capabilities that we would have only had previously through wired Ethernet type connections. Is that right?
Absolutely. We start talking about, milliseconds of latency instead of tens or hundreds of milliseconds, right? We start talking about 6 nines of reliability. So, 32 seconds of downtime per year. Just unheard of from a wireless technology. We're all used to, 4G and Wi-Fi and all these other technologies, Bluetooth and other satellite communications, but 5G is the first technology like this that's meant to address pretty much all those different applications, from the ground up, from the, coming out of the standards organizations, if you will.
Is there a good example of a use case where that was never migrated from hardwire to wireless that you can think of? And then the follow-up to that question would be, is there a good example of a use case that we just couldn't do because we needed this type of wireless and never had it that we will be able to do now? So kind of a two-part.
No, it's good question. I mean, the two that jump to mind, you get into manufacturing, right? And this idea that, with Industry 4.0, how you want to have factories that are more flexible in the sense of being able to reconfigure machines, reconfigure, process flows and things like that, but not requiring a week of downtime to, rewire the factory, if you will. You want machines to be able to move different places in the factory to reconfigure and have that flexibility of a wireless connection, but also no matter where that thing goes, it still has the 6 nines of reliability, has the 1 or 2 milliseconds of latency, et cetera. So it's a great use case as we go towards, Industry 4.0. John, the name of this podcast, Lights Out, I can only assume that's in reference to ultimately we'll get to factories so smart that there will be no lights on, there will be no people there. They'll just be, reconfigured and controlled remotely, right?
That's right. Yeah. Somebody gets it, Thomas. That's good because my wife makes fun of me that it's like a boxing reference or something. So.
So Andy, I think that's a great example that I think you guys can easily see and kind of what that means from now, not having to worry about the wired connectivity. The other side of your question, Andy, was about, what are the use cases that's enabling that kind of novel and such, right? For sure, everything in and around autonomous guided vehicles of any sort, right? So that could be, could be drones in a factory or in a disaster recovery mode where they need to send somebody in to kind of see what's going on. It could be autonomous vehicles, in and around a factory or a mine, or, as we get into autonomous self-driving vehicles, fleets of trucks that are platooning, through, connecting communication with each other. So having that high throughput, super low latency, 6 nines of reliability, really enables a new suite of use cases in and around autonomy that didn't exist before.
And a new kind of secure environment too. I think it's really important to point out, right? There's a big there's a big emphasis on secure private wireless networks that can now be deployed in black sites where military facilities or government facilities are taking place, or secure networks for disaster recovery, pandemic response. Even today with COVID, I've seen a number of companies that are popping up like these makeshift, hospitals and treatment centers, and those places need connectivity for patient records, to retrieve information, to store information. And I've seen some use cases where that might be relevant too. Just some food for thought. Yeah.
No, it's a good point. I mean, you touch on a couple of things there. One is we've seen with 4G LTE this move towards private LTE, like you were saying, with a factory or a mine or something like that. What's interesting with 5G is the support for use in unlicensed spectrum is built into the standard, right from the very beginning. So it's not just a a novel application of existing technology. Just take 4G and make it private 4G. It's built right in there from the beginning. So that's huge. So that's one thing that'll be interesting.
Can you elaborate on that for a moment? Like, what do you mean when you say unlicensed spectrum? I know the FCC delineates the spectrum and people can buy portions of it. Is that what you're referring to? That there's going to be some bit of it that nobody buys and that's left to be used in the private on a private network? Is that what you mean?
5G, the standards support in the 5 gigahertz spectrum. So this is typically what's used for Wi-Fi, right? If you have a 5 gig, Wi-Fi at home versus 2.5. So that's one that's kind of built in. You also have some new bands that are opening up, like around 6 gigahertz, that have never been used for this type of communications. So, and spectrum's kind of a thorny issue, right? Because it really is a country by country discussion, right? Every country has their own ways of mapping spectrum, using spectrum, and so it's hard to, it's hard to say there's a one size fits all for around the world from a spectrum perspective. I think, John, you kind of brought up the security topic. One of the really cool things that's built into 5G is this concept of network slicing, right? So that is where either an operator in a public 5G network, or, John, to your point earlier, a factory or a manufacturing or a mine that has a private 5G network, they can have one physical network, but they can have multiple virtual slices of that network running all at the same time, right? So you could have, one slice in a factory, let's say for the production environment, right? To actually run the factory with the lowest possible latency, the highest reliability, the highest security, et cetera, running on that network. At the same time, you can have another slice that's maybe just really almost like best effort, just the kind of the internal communications, the LAN, the people's communications. Doesn't really need that level of reliability, that level of low latency, and then you can have different slices in between. So that's one of the interesting things, and it also helps with the security then, because there's not just one size fits all network for 5G in that case. If somebody is coming in to try to attack your 5G network, it's sliced into all these virtual slices, makes it much harder for somebody to have a negative effect on it, if you will.
There's a big, the thing that's standing out to me, Andy, how many times have we gone into factories and we've done projects around data collection and aggregation to the cloud or to a data center, and we had to be really conscious about how much data do we want to send at given intervals so we don't flood the network or eat up all the bandwidth, or let's process as much as we can here so we don't bog down the rest of the systems, especially mission critical systems,
right,
throughout the factory. But that's what's jumping out to me about the slicing, is that kind of alleviates that pain, right? Interesting.
Yeah. One of the things in mentioning that, right, a lot of I was working for a big manufacturer. They make large metal pieces of equipment, and we tested traditional wireless technologies, but found that they were unreliable because you had these large metal objects that were being moved around the factory, and sometimes the signals would get blocked, and it would make it. It was funny, if you could track the movement of a crane, you knew when you were about to lose wireless signal because the crane was going to get in between the access point and the device.
Yes.
And as John mentioned earlier, know little about what constitutes 5G technology. And in fact, that was another question I had heard in the past, that 5G wasn't going to be like a single radio. It wasn't going to be a single frequency or something. It was going to be a multitude of technologies that get blended together for better service. But that whole, is it pardon my ignorance, but is there something about 5G technology that would help in that situation I was describing earlier, where the signal was what are the key components of 5G? Is it literally a frequency or range of frequencies in a new radio device that would work on those frequencies?
Yeah, no, it's a good question. When you look at 5G and some of the applications you're talking about there with connectivity and sharing that, so it is, despite the, or because of the name 5G from 4G, there is an evolution of, some of the frequencies that have been used in 4G. So say below 1 gigahertz, for instance, what's kind of considered the low band, those are still going to be used in 5G. And so there'll be some modest improvement in throughput, but not significant. But 5G is then opening up this mid band kind of between 1 and 6 gigahertz. I talked about, like, with the, reusing some of the unlicensed spectrum around 5G and 6G. So you start to get a better performance and lower latency. But the real promise of 5G is if you hear people talk about millimeter wave spectrum, and that's where you get up this high band from 24 to 100 gigahertz, right? And that's really the holy grail of 5G, because that's where you get the fastest speeds, the lowest latencies, for a network. The caveat, however, is the higher you go on the spectrum there from 1 gig up to 24 or 100 gig, the signal has more difficulty getting through buildings and walls and things like that, right? So what we're going to see is the initial 5G networks, like you've seen T-Mobile talking about, the best, 650 megahertz 5G available everywhere. It's true. They're basically using the same towers they have already, right? They're not having to go in and add more towers. However, if you look at what Verizon is talking about with their ultra wideband 5G, and they really, on the commercials, they talk about select cities, and the person talking about is standing in front of a sports stadium. What has to happen is those cells have to get a lot smaller, right? And so now, rather than lots of cell towers, you see the need for more and more what we call small cells, right? So this idea that you're going to have a small box, or multiple boxes located, in and around a stadium, a factory, a city, leveraging those millimeter waves up there at those higher frequencies, and collectively, it's going to provide, the reliability and the throughput that we're talking about. So that would overcome some of these issues you see today,
Sure.
Because you're going to have more, more.
You kind of flood the area with access points is
effectively, yes, and that's why 5G is it's going to take some time to really roll out and all the benefits of gigabit speeds and everything. It's not a flip the switch and it's ready tomorrow. It's going to take a little bit of time to get there.
We want it now, Thomas.
yeah.
Exactly.
And everybody's gonna ask, right, what's the cost? Like, how much, incrementally speaking? And it doesn't make sense to do it in real dollars, because that could fluctuate for everybody in every situation. But percentage wise, are we talking like, is the equipment less? Because I hear more equipment.
Right.
So, what are some of the costs, some of the financial sides of going to 5G?
Sure. So, if you think about, you try to compare apples to apples. So let's just say 4G in that low band, that less than 100 gigahertz, and 5G in that low band. That would be a good apples to apples comparison. I believe 5G is going to be less expensive overall, because 5G is a end-to-end software-defined architecture, right? So all the the core elements, everything that goes into the access network and the core, it's all done in software, right? So now rather than dedicated eNode Bs or hardware from Ericsson or Nokia or folks like that, they're basically selling commercial off the shelf rack and stack processors, right? And everything is done with virtualization, NFV and things like that, right? So in theory, you're buying off the shelf hardware, and you're doing everything in software, and you're only then, having to pay for those functions that you need. At that time, it opens up a lot of interesting things with software as a service, a feature set. An operator may not need all that feature set, whereas before they had to pay for the hardware to support that whole feature set. Now, by just turning up those features in software, on a Dell or somebody's, off-the-shelf hardware, they can, more easily map investment to revenue, right? So I think that there'll be some savings there. Certainly, to build out this 22 gig, massive millimeter wave network is going to be expensive. And so we're not going to see that everywhere. We're going to see that in concentrated places, like I said, stadiums, downtown, factories, things like that, industrial parks, et cetera.
Where it's been happening for a long time already. Actually, a lot of people probably don't know this, but when you go to a stadium or a big conference center, something like that, you're not on, in many instances, you're not really on the outside world cell network, right? Because you've just stepped into essentially a concrete fishbowl,
right?
In many ways, right? There is no cell signal in there. And a lot of people don't know that, but I've had the privilege of getting some behind the scenes tours around where the Atlanta Hawks play and Miami Heat and all these places. And when you're a nerdy guy like me and they walk you around the building, they point out all of the cellular connectivity hotspots and all these things. It's pretty interesting, but it really is amazing how they have created those private networks just so you can use your cell phone inside of the event. And it's totally custom tailored in many respects to what we're talking about today with what will become more of the norm with 5G as we work to put nodes throughout cities and throughout buildings to help get access to it. So that's kind of interesting. One other thing that you said, Thomas, that's pretty interesting too. You mentioned that in many respects, it's a hardware or a software change that's coming to bring a lot of speed to folks and things like that. That made me think of something that I had that I had heard about that I'm not so sure a lot of people know about, some of the relationships that are starting to form between the hyperscalers and cloud providers and your telco providers, right? When you look at the Verizon AWS relationship, for example, where AWS is now taking essentially what makes AWS so powerful, the hyperscaler technology in the cloud, they're actually now installing that in the Verizon data centers. And so what that means is historically you would you would do some kind of data processing on a cell phone, let's say, for the sake of argument, right? So I want to go browse Facebook, whatever, right? My cell phone has to communicate back to the Verizon servers, which then sends my request out to the internet, gets a response, comes back to the Verizon servers, puts it on my phone, right? Is that a dumbed down fair way to say it? How historically it works? And so now what this marriage, if you will, between the telcos and the hyperscalers, what that really means is that the cellular traffic now no longer has to leave the telco's infrastructure. So you don't have to go out from the Verizon data center out to the internet. All of the data processing now happens directly in Verizon's data centers. And that's, I think, largely one reason why we see this massive speed boost, because we just removed an entire layer of this cake.
No, absolutely. I mean, what you're referring to there is this whole push on edge computing, right? So this idea that, rather than have compute and storages up in a centralized cloud, you now push that closer and closer to the user, to the factory, to the enterprise. In your example, in the Verizon central office, if you will. And so that kind of goes hand in hand with 5G. So 5G is going to provide that over-the-air, super low latency, a few milliseconds, right? Having that compute power right there next to the radio, if you will, or next to the mobile core to do that computation keeps the latency low, increases the performance there for whatever application is in the factory, right? But it also, another thing too, and this is something I've been arguing on LinkedIn that people don't seem to latch on that often, is security, right? Yeah. If you're a production facility and you're gathering all this data on your machines and what's going on, and you want to be able to do some, performance, some calculations, leverage some AI or some machine learning to draw some insights from it. If you got to ship it up to the cloud, literally, hundreds of miles or whatever, into a centralized cloud to where it resides and gets processed, that's a security issue, right? I mean, it can be encrypted, yes, but if you can keep that data as close to the factory as possible, or even in the data center within the factory, that's all the better, right? You not only save the cost of transit, but that data just never leaves the starting point, right?
Yeah.
So that's a big one.
Security is a big topic for sure. By the way, I have to plug you here, Thomas. If you don't follow Thomas Fuerst, if you're not connected with him on LinkedIn, I'm going to put it on the screen here how to connect with him. I'm going to put it in the comments. You have to connect with him. He's always he says arguing with people. I wouldn't say that. I think you bring a creative view and a challenging perspective, which that's, you're one of my favorite people to follow, especially in this space, because
Excellent.
I just love how you challenge people to think a little bit differently and outside of the box. And one of the most recent places where you did it, it was related to a speed chart from one of the analyst companies, and I'll put it up on the screen here so the viewers can see it. But what it was is it's a chart that shows that we are in dead last place when it comes to speed of 5G. When I say we,
right,
by the way, I mean the United States, right? If you rank us compared to the UK and Switzerland, and I think the UAE was on there and all these other places, we're dead last.
right.
I don't know why that is. Why is that?
Well, it goes back to the spectrum thing we were talking about earlier, right? So and I don't know if it's in that same report, but there's places where it shows, which countries have set aside which spectrum for 5G, right? So I think in UAE and some of those countries where you have a very urban population, right? It's easier for them to start with some of those higher frequencies. Let's say the 6 gig, or maybe it's the millimeter wave up at 22 or 24. I'm not sure. It's easier for them to start with that because they have a much more dense population, right?
Okay.
And serve that and get the benefits, like I said, of the higher speed and the lower latency, the holy grail of 5G, if you will, versus you think about the US, where you've seen, like, again, T-Mobile kind of jumping out and saying, we've covered the country with 5G, which is true. They're doing it, at a sub 1 gigahertz speed. So the difference between 4G and that 5G is going to be nominal versus what this 22 gig speed might be. So that's what I was trying to get at with that comment, is that, we really need to be careful here about apples and orange comparison. But there's also, something to say for government sponsorship, government direction. So look at South Korea. For instance, they've always had a very strong government stance towards being a broadband nation. We saw it with, fiber in fiber to the home, things like that, but also with 4G and now with 5G. So there is a benefit that can come there as well.
Well, Thomas, I think we've used up enough of your time. Really, really appreciate you joining us, and very valuable insights. Again, encourage everybody to connect with Thomas on LinkedIn if you haven't already done it by now. It's been 20 minutes, so I don't know what you're waiting for.
Right. What are you waiting for?
I'll put his info again in the comments here in the description. And as always, leave a comment, like, and subscribe, and we'll see you guys next time.
Excellent. Thanks, John. Thanks, Andy.
Thank you.